Alright, little Walter update. Yeah, really, a Walter update. Okay. Walter's old motors. Alright. Walter's new motors. Much happier here. We're down to about a 4 amp draw. Not even, about 3 amps, 4 amps when it's really working hard. Locks in position when it's off. Super duper happy here. Now, right here I have a QRD 1114 optical sensor for my encoder, and inside of this is one of these. You can see my black finger from painting it. Okay, so I have one of these. I left the blue plastic on this one so you can see it. Here is what it looks like together inside. Alright, so there's two of them stacked up, make it a little thicker. And what I've done is I painted the whole thing. I glued them together, and then I painted the whole thing matte black, and then I painted just the tips of these guys white. So that's 4 counts per revolution, and that is these are a press fit around the shaft of the motor, and then it's the worm gear, and then it's the main gear, and then geared again 7 teeth there to 42 teeth on the main drive wheel. And so basically that optical sensor excuse me, catches each one of these tips as they go by, as they are painted white and the spaces between are painted black. And I have got to tell you, well, a couple things. A, I'm super duper happy because I'm finally running my encoders off of the shaft of the motor pre-gearing, as opposed to the slot encoders I used to use on my wheels. So super duper happy there. But I'm even more happy with that. Now, I must admit, it is not a square wave. Not even close. It's kind of a whoop-de-doo wave, but nevertheless, this reference line, that's 0.26 volts. And if you go over here to the peak, 3 1/4. So, and this is with a 3.3 volt supply. So my high is as high as it can go. It's like 3.2 something, 3.3 out of 3.3, and then my low is as low as it can be. It's 0.026, I think I measured it at. So, and I'm counting, where are my notes? I'm counting 3 highs and 3 lows in 20 milliseconds at sort of an average speed. So at 100 milliseconds, that's 10 PID checks per second. I'm at 30 counts. So that's not bad, actually. That, in theory, out of 30 counts, considering maybe 20 will probably be as low as it can go. If I do 1 count per speed, that means I have 10 steps of speed. Possibly more going faster. So, point is, I have never seen any of my encoder waves that even. Like, you can even see, look at this, like, if we start here, 1, 2, 3, goober, 1, 2, 3, goober. So there's probably a scratch in the white paint on that lug coming around, which is cool. But still, it's the cleanest high and the cleanest low I think I've ever had, and just perfectly even. So my PID routines should work extraordinarily well. So there you go. There's one of Walter's motors. I got one more to build. But so far, extraordinarily happy. And now that I see that, I couldn't be happier with this encoder. So, and again, I'm not using any caps. I'm not using any A to D or D to A converters or anything. It's just a pull up on the sensor, and that's it. And it's coming out that clean. as a digital signal. So, well, not digital, but digitally enough, high and low enough to click a digital pin. So, there you go, Walter update. Ting!